Thank you, Fiona. Good afternoon, everyone, or good morning in some of the time zones, and welcome to another session in the AWS APAC Webinar Week. My name is Namjit Cho, and I'm a solutions architect based out of our Sydney office in Australia. And in this webinar, I'll be teaching you about the top 5 ways to optimize for cost efficiency with the cloud. So what will you get out of this session today? Well, I'm going to tell you how you can lower your AWS bill while still maintaining a highly performing and highly available application on the AWS Cloud. You're going to learn how to deploy highly scalable, robust, and dynamic architectures in the cloud, and at the same time, how you can optimize the costs of running applications in the AWS Cloud. This will release you from the traditional approach of application deployment and allow you to spend more time on things that matter to your business and your organizations. And not to be bogged down by the things that don't really add value to your business, like deploying and maintaining infrastructure and data centers. I'll be showing you some real-life examples and case studies where many of our customers around the world are leveraging the AWS Cloud to create value in their businesses. For the benefit of the audience who are at the start of their cloud journey, or those who have not taken the first steps to cloud, let me start by telling you about some of the key benefits of cloud computing and the reasons why so many customers have already deployed their solutions on AWS. AWS provides highly scalable computing infrastructure that enables organizations around the world to purchase compute, storage, database, and other on-demand services on an on-demand model completely in the AWS Cloud. Customers access the services when they need them and pay for only what they use. One of the primary benefits of AWS Cloud is that it enables companies of all sizes to focus on the differentiating factors of their business, as opposed to, say, spending time on infrastructure which is required to run on it. One way to think about cloud computing is that instead of buying, owning, and maintaining your own data centers or servers, businesses and developers can acquire technology resources such as compute, storage, databases on an as-needed basis. AWS manages and maintains the technology infrastructure in a secure environment, and users interact with resources via the web services and APIs. Your cloud capacity consumption can grow or shrink instantly and on demand in accordance with your business need. There is no need for you to over-provision your capacities as you may do in your own data centers today, as you can scale up or down as your demand as per your business demand. And to summarize, AWS believes cloud computing offers the following core characteristic. There should be no upfront capital expenditure, and all services are pay-as-you-go services. Capacity should be truly elastic, which means you can scale up and down instantly as needed. It should allow you to move very quickly and provision servers in minutes, and finally, allow you to focus and allocate resources on the areas that differentiate your business instead of infrastructure required to run them. So in today's webinar, we'll be focusing on the first 3 benefits of the cloud computing I just mentioned, which is pay-as-you-go, no upfront investment, low ongoing cost, and flexible capacity. But you do not have to sacrifice performance and availability. I'll tell you how you can maintain high performance and availability in your applications running on the AWS Cloud while still maintaining low cost. So what are some strategies available for AWS customers to optimize and reduce their running costs on AWS Cloud today? The first strategy is do nothing. Although that might sound a little bit strange, by taking no action at all, our customers have managed to lower their cost of running applications in the AWS Cloud. You may ask, how did AWS customers achieve cost savings and efficiency by taking no action? Well, since 2006, there has been 48 price reductions on the AWS Cloud, and on a dozen occasions over the last few years, we've had price reductions with no competitive pressure to do so. This is very different business than traditional IT, and we think we're quite good at running high volume and low margin business. we have a virtuous circle which is illustrated by the diagram that you see in front of you. So the virtuous circle goes, as we have more customers using AWS, we buy more infrastructure. And as we buy more infrastructure, we've been lowering costs, which in turn attracts more customers. So as AWS achieves greater economies of scale, we can pass the savings on to our customers in the form of price reductions, and the cycle continues. So this is one way our customers have been able to save costs of running on AWS, and will continue to do so in the future. So our next strategy is do almost nothing. And the way you do that is by leveraging some of the tools and the dashboards and the data that AWS will provide with respect to your spend on AWS. And one of the ways you can do that is by a tool that we provide called AWS Trusted Advisor, which acts like your customized cloud expert, and it helps you provision your resources by following best practices. The AWS Trusted Advisor inspects your AWS environment and finds opportunities to save money, improve system performance and reliability, and help to close your security gaps. Since 2013, customers have viewed over 1.7 million best practice recommendations and realized over $300 million in estimated cost reductions just by utilizing our AWS Trusted Advisor. You can start with a free version of AWS Trusted Advisor in the AWS Management Console with 4 of the most popular performance and security recommendations, and access to these checks never expires. All of the AWS Trusted Advisor checks are available to customers with business level and enterprise level support, and the best practice recommendations can be integrated into your applications through the AWS supported APIs. AWS Trusted Advisor provides best practice in 4 categories: cost optimization, security, fault tolerance, and performance improvement. You can use over 30 Trusted Advisor checks to monitor and improve the deployment of your Amazon EC2, Elastic Load Balancing, Amazon EBS, Amazon S3, order scaling, and all of the other services. You can view the overall status of your AWS resources and savings estimations on the Trusted Advisor dashboard. So start using AWS Trusted Advisor today to save money and optimize performance and improve the security of your AWS deployment. So this brings us to the part of the webinar where I'll tell you how you can optimize your cost and reduce your spend on your AWS through architecture optimization. The title of this webinar suggests that I'll be presenting you with 5 ways to optimize for cost efficiency. However, there are many more ways than 5 to optimize the cost efficiency on AWS, and I really wanted to tell you about the key ones in this webinar. So we'll probably go through a little bit more than 5, and I'll describe them as we go through this section. So let's have a look at a basic process of old versus Amazon Cloud, the process of old world versus Amazon Cloud world of solution deployment. When you look at the old world process of how an application is designed and deployed in traditional data center, it can often take weeks or even months to go through from planning through to the run phase of your application deployment. However, in the new world of cloud computing, our customers are achieving rapid application deployment by utilizing a combination of feature-rich cloud services from AWS and combining them with automation, DevOps, continuous integration, and continuous delivery frameworks to deliver these solutions and applications faster into the AWS cloud. So how do we architect for low cost on AWS cloud while maintaining high performance and availability in your applications? Well, I'm going to share with you how you can architect for low cost and high performance on AWS cloud in the 7 easy steps. And the first one is turn off your unused instances. This may seem like an obvious one for saving costs on AWS, and it is. And in AWS, our philosophy is that customers should only pay for what they use, but at the same time, the services should always be available to the customers on demand whenever they want to use our cloud services. What many of our new customers don't realize is that our EC2 service is an on-demand service that you can switch on and off at any time. And when you switch off your instances, as long as you save your data on AWS EBS storage, your data will be persisted, and next time you restart the instance, all your machine state will be restored. So this is a great use case if you have your projects or your dev or your test environments or training environments which aren't usually required to be online 24/7. So if you only need to use your development system or your test system for 8 hours of the day, you just simply switch them on when you get in the morning, and then the last person who leaves for the evening can switch the systems off. Alternatively, you can use the AWS APIs or the command lines or SDKs to automate the switching on and switching off of your EC2 instances so that all the startups and shutdowns are automated through the schedules using our APIs. So typically customers who run, say, as I mentioned earlier, typically customers who run non-production environments such as test and training, they don't need to run the systems 100% of the time. So another way that you can use our SDKs and to schedule and start to stop is you can assign tags to identify your instances that are in your development, test, training, or even production environments. And you can schedule a start and stop scripts to read the tags and only act on instances that are classified as non-production. And as our customers' usage of cloud matures, we have customers who use DevOps and CI/CD framework to perform complete teardown and rebuild of the environments as and when they need it. And remember that EC2 instances are disposable. Tear and rebuild them anytime by using Amazon Machine Images. So this chart in front of you shows a real-life example of customers who is actively starting and stopping their EC2 instances to save the running costs on AWS. The vertical axis on the chart shows the total number of instances running, and the horizontal axis shows the timeline in hours. As you can see from the chart, customers' total running instances fluctuates, especially on weekends and holiday season, which allows them to achieve a cost saving of 35% in comparison to if they ran the systems 24/7, especially during the times when they don't actually need to use the system. And here are some of our case studies from our good customers who have managed to achieve cost saving on running on AWS just by switching off their instances. Pfizer, the pharmaceutical company, run a high-performance computing on AWS and uses a scheduler to stop-start instances as and when they need it to address the workflows. Run E2E for Kenneth Cole and Sage both utilize similar start-stop strategies to optimize usage and eliminate unnecessary costs. All these customer case studies can be found on our website, so please go to your favorite search engine just by searching on AWS and the word customer case studies. You will be able to find a lot of these case studies on our website. So next one up is the use of AWS auto-scaling. And this is one of my favorite services on AWS. Why? Because for a service that is so simple to use, it delivers so many important functions to achieve scalability and availability for applications running in the AWS. Auto-scaling helps you maintain application availability, and it allows you to scale your Amazon EC2 capacity up and down automatically according to conditions that you define. You can use auto-scaling to help ensure that you are running your desired number of Amazon EC2 instances. Auto-scaling can also automatically increase the number of Amazon EC2 instances during demand spikes to maintain performance and decrease capacity during, say, lulls to reduce costs. Auto-scaling is well suited both to applications that have stable demand patterns and that experience perhaps hourly, daily, or even weekly variability in their usage. Here on the diagram you see in front of you is an example of a two-tier web application with auto-scaling on the web layer. That's illustrated by that little orange arrow that you see. By using our Elastic Load Balancer within your auto-scaling group, any instances which are launched by the auto-scaling group event will be automatically added to the Elastic Load Balancer, and the traffic will be routed to the newly launched instances. It all works in reverse. When instances are terminated by auto-scaling event, the instances will be automatically removed from the Elastic Load Balancer, and the traffic will stop getting routed to the terminated servers. And with the functionality that AWS provide, it will drain the load balancers and then take the instance out gracefully, so that your connections from your end users aren't being dropped abruptly. And auto-scaling is actually really, really simple to deploy. This is the CloudFormation template that you see in front of you is an example of the auto-scaling launch configuration. And it is essentially less than 20 lines. And in addition to CloudFormation, you can also use the AWS SDK, the command line tool, or even the AWS Management Console to configure and manage your auto-scaling groups. So align your resources with demand. So auto-scaling enables you to follow the demand curve of your applications closely, reducing the need to manually provision Amazon EC2 capacity in advance. So for example, you can set a condition to add new Amazon EC2 instances in increments to the auto-scaling group when the average utilization of your Amazon EC2 fleet is high. Say your CPU utilization is above 80% for longer than 10-minute period. And similarly, you can set a condition to remove instances in the same increment when the CPU utilization is low. If you have predictable load changes, say for example, you're doing a month-end close in your financial system, and you know that the last weeks or the first weeks of the month is going to be very busy, you can set a schedule through auto-scaling to plan your scaling activities as well. You can use Amazon CloudWatch to send alarms to trigger scaling activities, and Elastic Load Balancing to help distribute traffic to your newly added instances from your auto-scaling groups. Auto-scaling enables you to run your Amazon EC2 fleet at the most optimal utilization, and also this helps to reduce or optimize your cost of running your applications on AWS. So here are some more customer case studies for that. These are some of our customers, and we have many, many more who use and reap the benefits of auto-scaling. Netflix, I hope everybody knows, video content delivery and video streaming service. Siemens is a large multinational in all areas of across many different industries. And the last one there is ticketleap.com. Is using an array of AWS services, including auto-scaling. Again, all of these case studies are a great example of how our customers are using AWS and the auto-scaling to optimize their cost and efficiency. So I would urge everybody to check out the case studies, which are available on our website. And another really, really great resource for learning about AWS and how our customers use them is many of our customers actually release technical blogs about their usage of AWS. And if you go to techblog.netflix.com, they have some really, really great write-up about how they're utilizing AWS, not just for auto-scaling, but across all of the different services. And it is a really good, great tool for not just learning about how a customer can benefit from AWS, but it's a great way and I use it all the time, to pick up new technical skills on how Netflix is changing the way that they are running the businesses in the cloud. So third one is the usage. Third way to optimize your cost on AWS is through using our reserved instances. So reserved instances provide you with the ability to maximize your level of savings by purchasing a reserved instance that meets your business needs. Our AWS offers reserved instances for 1 or 3 terms, and reserved instances are available across all our regions. Reserved instances are also available for instances that you run in Amazon VPC and also in the dedicated instances. So reserved instances can be purchased for Amazon EC2, running a Linux, SUSE, Red Hat, Microsoft Windows Server, and also we also offer Windows Server with SQL Server. You can choose between many different payment options. We have an all upfront option to no upfront option. And essentially what that means is that depending on the which option you choose, you can choose to pay it all up front and get the maximum savings from day one, or alternatively, you can commit to a 1-year reserve or a 3-year reserve without any upfront payment, and decide to amortize that cost over the 12-month period by paying a regular monthly fee. So here is a chart comparing the cost of running EC2 instances using on-demand versus on the 1-year and 3-year reserved instance pricing. If you know that you're going to be running a workload that requires consistent 24/7 workload over a period of 1 year or 3 years, I would highly recommend that you consider using reserved instances to save money. You can use the AWS Pricing Calculator, which is available to everybody on our website, to calculate the cost of on-demand versus reserved instance pricing. The diagram that you see, the chart on the bottom left-hand there, what that is trying to illustrate is that if you run your EC2 instances on an on-demand pricing and compare that to the 1-year and 3-year RI, your break-even point for a 1-year RI comes out around about 6-month mark. That means that if you know that you're going to be using your EC2 instances for greater than 6-month period and it's going to be on 24 hours a day, then after 6 months on the RI pricing, you would essentially have got your payback in comparison to the on-demand pricing. Now, we have a lot of information available about the reserved instance pricing on our website. We also have a number of videos that we post up on YouTube that you can check out, and they are a great resource for learning about how the reserved instances work. And if you need some help with a better understanding your reserved instance pricing, please get in touch with us, and we'd be more than happy to help you out with how you can save money by utilizing reserved instances. So just a few things to remember about reserved instances. We have, there are some misconceptions out there about the reserved instances, and I just wanted to point out that reserved instances are actually quite flexible. They can be moved between availability zones within AWS, and they can also be moved between our EC2 Classic and our EC2 VPC platforms. And also the sizes of the reserved instances can actually be modified within the same instance family. So if you've deployed within, say, a C3 family, and you wanted to move to a different size within those C3 family, you can easily do that by going to the reserved instance console and essentially just purchasing the difference, or you can even split out the RIs into smaller instances within the same family. So I think if you've been an AWS customer for some time, you perhaps would be running your instances on the old RI model, but just remember that. So apologies, there is some misinformation on this slide. We've had a simplified RI model for some time, and they are the 3 options that you see in front of you there, and you can find more information about that on our website. So a great case study about customers utilizing reserved instances. Zumba Fitness is some of you might be familiar with. It's actually one of the dance fitness programs around the world, and they've managed to save up to 39% on their computing resources by reserving instances for their EC2 usage on AWS. And the next one is a use of spot instances. So spot instances allow you to essentially name your price for the Amazon EC2 computing capacity. You simply bid on a spare Amazon EC2 instances, the spare capacity that we have within our regions and availability zones, and run them whenever you can run them whenever you bid in exceeds the current spot price, which varies in real time based on supply and demand. Spot instance pricing model complements the on-demand and reserved instance pricing model, providing potentially the most cost-effective option for obtaining compute capacity depending on your application. Spot instances can significantly lower your computing costs for time-flexible and interruption-tolerant applications and tasks. Additionally, for some distributed fault-tolerant tasks like web crawling, you may be able to simultaneously accelerate your computational task and reduce its overall costs by opportunistically incorporating spot instances. So what are the rules for spot instances? It's actually quite simple. Pricing is based on supply and demand, so you are effectively bidding for the spare capacity that's available at any point in time across all AWS regions and availability zones. You choose the maximum price per hour that you want to pay, and your instance is started if the spot instance pricing goes below your bid price. But remember that if the spot instance pricing goes above your bid price after launch, your EC2 instances will be terminated. So you need to architect your solution to withstand and handle the spot instance terminating instantaneously. Here's an actual example of the spot instance pricing history of the M1 large instance type in the 3 availability zones in the US East region between 18th and 24th of October last year. As you can see from the chart, the spot pricing actually differs significantly at times between all the 3 availability zones, even though they are all within the same AWS region. It also demonstrates that spot instance pricing fluctuates well below as well as well above the on-demand pricing. So please read our documentation on spot pricing and understand its clear use case before you commit your workloads with spot instance pricing. So some of the use cases that you may use spot instance pricing. Using Amazon Elastic MapReduce for big data processing is a great use case for spot instances. We have many customers taking advantage of spot instance pricing on their EMR clusters, and we'll show you some customer case studies later in this presentation that demonstrates that cost saving. It's also great for web crawling, financial data modeling, such as Monte Carlo analysis, and it's a great way to do, say, testing and image and media encoding. A lot of our high-performance computing customers utilize spot instance pricing, and they get huge cost savings in comparison to using, say, on-demand pricing, or even in comparison to reserved instances. But just remember that if your workload and the use case can be used with spot pricing, it's very likely that it's not going to be suitable for reserved instance pricing and vice versa. So just to recap, spot instance pricing is very dynamic, and there is opportunity for you to save 80 or even 90% of the cost when compared to on-demand pricing. However, please bear in mind that not all applications running in the cloud are suitable for spot instance, and I would highly recommend that you design around it up front. Finally, you can take advantage of spot instances with auto-scaling using the auto-scaling launch configuration and get the best of both worlds, the spot and on-demand instance pricing. So, the case study. HGST buys 70,000 core cloud HPC cluster and breaks record and returns it in 8 hours later. This is a case study from our good partners at Cycle Computing, who deployed a 70,000 core compute cluster across 3 AWS regions. As you can see from the stats, they managed to get through almost 71 years of compute in just 8 hours by utilizing the power of AWS Cloud and taking advantage of the spot instances. In this case, 5,689 spot instances were up and running at its peak. All this compute processing was completed at an amazingly low cost of $5,594, and that is for 70,000 core compute cluster. You can read more about this on our Cycle Computing's website, and we can provide that with you, the link afterwards. So next up is Amazon Simple Storage Service, or S3, and Amazon Glacier. So many of our customers use S3 and Glacier for storage, for backups and storing their objects for web applications. And what many people forget about S3 is that it actually comes with two different durability options. The default option comes with 11 nines of durability. However, if you're storing a lot of objects and data in S3 but don't require the high level of durability, or 11 nines of durability, you can save cost of storing the object while still maintaining the same read-write performance by choosing the S3 reduced redundancy. This provides you with 4 nines of durability and comes at 20% lower costs. So if you're storing multi-terabytes or even multi-petabytes of objects, a 20% cost saving can become quite significant. You can also use the lifecycle management rules in S3 to either archive objects to Amazon Glacier or even delete the objects after a predefined number of days so that you're not incurring the cost for objects that are no longer required. The next one is the optimization of Amazon DynamoDB capacity. So within Amazon DynamoDB, the read-write capacity units determine most of the the DynamoDB costs. So by optimizing the capacity unit, you can save a lot of money. But remember, you need to provision enough capacity to run your application so that you don't run into capacity errors, and you need to prepare for the peaks, and you need to monitor and adjust constantly as you run your applications on the back of the DynamoDB. So DynamoDB optimization, using caching to save read capacity units. So local RAM caches at app server instances. What that means is that you can design your application to cache the most commonly used data within the caching layer of your application, so that you don't have to keep going back to DynamoDB to read data. Also, you can utilize the Amazon Elasticache for Redis or Memcached to cache your data while it's being, and you can run it in parallel with your DynamoDB. And this will also allow you to save your capacity units. So think of strategies for optimizing your capacity units, which means that you should use multiple tables to support varied access patterns, and also understand access patterns for time series data, and also compress large attribute values. And finally, think about putting a queue into your architecture, such as Amazon SQS, so that you can buffer your capacity or overcapacity writes with the worker process, so that you don't have to put all the capacity units that you need for the peak on the DynamoDB. So here's a really good case study from our customer Shazam, and they've written this blog on their website, and it's a very good blog about using Amazon SQS to buffer requests and throttle DynamoDB throughput. So this allows them to still meet their demand for their throughput, but at the same time they don't have to deploy a very high capacity unit on their DynamoDB, and hence this allows them to save a lot of costs of running the DynamoDB. So as I said, this is a case study around the Shazam's usage of DynamoDB during the Super Bowl 2012. Again, go ahead onto our website and check that case study out, and also check out Shazam's blogs on their how they're using the Amazon SQS with DynamoDB to cache and queue the write requests. And for the advanced users, if you want to get even more sophisticated, check out the dynamic DynamoDB project on GitHub, which provides a solution for automatic read and write provisioning for Dynamodb. So this is dynamically increasing and decreasing the capacity units. So let's have a look at a chart of a real-life customer example of how they managed to save 80% of cost of running Amazon Dynamodb by using the caching and optimization recommendations I mentioned in my previous slides. By using caching and dynamic Dynamodb, customer only pays for around 2,000 capacity units as constant load, but can automatically scale up to much higher capacity units only when it's needed. So the final recommendation for optimizing cost while maintaining high performance is to offload your architecture as much as possible. The more you can offload, the less infrastructure you need to maintain, scale, or even pay for. And there are 3 easy ways to offload your architecture. The first one is using a content delivery network such as Amazon CloudFront. And secondly, you can introduce a caching layer with Amazon ElastiCache, which offers Redis or Memcached. And finally, final way to offload your architecture is utilizing as much of the Amazon Web Services. As you can see from the chart on the left, offloading your dynamic and static content to a CDN can improve the performance of your web application as the response time is reduced and your customer gets a much better user experience on your website. In addition, you will reduce your AWS running costs as you'll need less back-end web servers as a CDN is taking care of delivering static and dynamic content directly to the user, and therefore is not using your infrastructure server resources to deliver that content to the user. So here are some really great customer case studies from Airbnb, IMDb, and PBS. Airbnb is, as everybody would know, is an online community marketplace for unique vacations. So this is a accommodation booking that is run entirely on AWS, and the solution is delivered. They use many of our services, including Amazon CloudFront, to offload their architecture. And same goes for Internet Movie Database and PBS, and they both use CloudFront to deliver static and dynamic content to their end users. So Amazon ElastiCache is a web service that makes it easy to deploy and operate and scale an in-memory cache in the cloud. The service improves the performance of web applications by allowing you to retrieve information from fast managed in-memory caches instead of relying entirely on slower disk-based databases. So as I mentioned earlier, ElastiCache supports 2 open source in-memory caching engines, Memcached and Redis. Amazon ElastiCache automatically detects and replaces failed nodes, so reducing the overhead associated with self-managed infrastructures. It also provides a resilient system that mitigates the risk of overload of databases, which slows websites and application load times. Through integration with Amazon CloudWatch, Amazon CloudWatch provides enhanced visibility into key performance metrics associated with your Memcached or Redis nodes. So, and here are again some customer case studies. PlaceIQ, Dynamodb, and Sparefoot, who are utilizing the Amazon ElastiCache to offload their architecture. Again, I would urge you to go to our website and check these case studies out. They are a great example, and you can learn a lot of things about how you can deploy your architecture and offload your architecture to the AWS Cloud. So, leveraging existing services. So when I meet a new customer, I'll typically, one of the first services that our customers usually adopt is the Amazon EC2, which is the Elastic Compute Cloud, which is our virtual machines on demand. But what a lot of our customers don't realize is that we have over 45 services on offer at AWS, and they include database as a service, we also have Cloud Search, which is a fully managed search engine, and Elastic Transcoder, which is video transcoding and audio transcoding in the cloud. And we also have a managed Hadoop as a cluster, a managed Hadoop cluster called Elastic MapReduce. So rather than you building all these different solutions in your own infrastructure or even on EC2, you can actually just utilize many of the services that we provide as a service to offload your infrastructure as well as your solutions to the AWS. So I would really, really recommend that you take some time out to check out all of the services we have available on AWS and study our reference architectures available on our website to learn how to architect a solution by utilizing and leveraging the AWS services. So this brings us to the next section of the webinar, which is cost monitoring and analysis. So in this section, we'll spend some time going through tools which are available to monitor and analyze your spend on AWS. This is very important because you want to be able to closely monitor and control your spend on the AWS cloud. And the first up is the AWS Tco Calculator. You can use the Tco Calculator to compare the cost of running your applications in an on-premises or a traditional hosting environment to AWS. Typically, customers will use the AWS Tco Calculator to estimate the TCO of running their solution on AWS versus on-prem or hosting environment before they deploy to AWS. See, AWS Tco Calculator provides a good cost comparison between the AWS Cloud and traditional deployments, even before you commit to any deployment options. So an AWS Tco Calculator is available right now at the URL on the slide, and it doesn't cost you any money to use our Tco Calculator, and you do not need to have an AWS account to use that Tco Calculator. It is available to everybody today. So I would, again, recommend that you check it out. So in terms of customer case study, there's a really great video from the global CTO of Dow Jones talking about how News Corp, and Dow Jones is a News Corp company, plans to achieve over $100 million over 3 years by closing down many of the data centers globally and migrating their workloads to AWS. So please check out the YouTube video, and many of the case studies are demonstrating the TCO benefits of AWS on the YouTube channel. So the next one is the AWS Simple Monthly Calculator, and for our existing customers, you may be very familiar with the AWS Simple Monthly Calculator, which is again available online, and you don't need an AWS account to access the calculator. The calculator helps you to estimate the cost of running your application on AWS Cloud before you start consuming the services. So you have a good idea of how much it's going to cost you to run the applications in the cloud, and you can budget for the cost of your deployment prior to you actually deploying it. At AWS, we publish all our pricing online, and we are completely transparent on our pricing, so there are no hidden costs. AWS Simple Monthly Calculator already reflects the latest pricing, so you can simply put the services you want to use, and the pricing calculator will provide a pricing estimate output for you. And when you open an AWS account and start consuming our services, you will receive a bill every month which provides a detailed breakdown of all the services you consume during that month. And the dashboard you see in front of you is a summary screen of your AWS bill, but this bill you can then drill down into each of the different sections to give you a even more detailed breakdown of where your consumption came from for that month. You can access the AWS billing console via your AWS management console from your browser. The data on the billing console is actually updated every 4 to 6 hours. So you can actively monitor your AWS spend throughout the month and keep a close eye on what you're spending on AWS deployment. As part of the billing console, you also have access to the AWS Cost Explorer. The Cost Explorer is a dashboard that shows you your month-on-month spend on your AWS account across all the different services, as you can see from the dashboard in front of example dashboard. Using the Cost Explorer together with the Trusted Advisor is very useful in understanding your AWS spend and the actions you take to optimize the spend. This is my final slide, and if you only remember one thing from today's webinar, I would really like you to remember this slide, which is the billing alerts. In your AWS account, you can set up an automated billing alert which can send you a message when the spend on your AWS account reaches your predefined alarm amount. For example, if you want your AWS account to notify you when your AWS spend for that month reaches $100, $200, $500, etc., you can set up billing alerts at each of those limits at the desired amount. And by setting the billing alerts at these different amounts, you can avoid bill shock at the end of the month and proactively monitor your spend throughout the month. Also, if you or someone in your team forget to stop or terminate a large cluster of EC2 instances, billing alerts will send you an automated message that tells you the spend on your AWS account has reached the threshold that you've defined, and you can take corrective action to stop or even terminate the instances. So let's recap what you learned today. So the 7 things that I went through just then: turn off your instances, use auto-scaling, use reserved instances, and also utilize our spot instance pricing. Leverage the different storage classes and Amazon Glacier for our storage service, and optimize your Amazon Dynamodb capacity units through the use of different available tools. And finally, you offload your architecture to all the different services that AWS can provide, including the CloudFront for CDN and also the Elasticache for Memcached and Redis. And finally, remember to continuously iterate by architect, build, and monitor, going through the architect, build, and monitor cycle. Through this continuous improvement cycle, you'll be able to achieve greater performance and cost saving in the long run. And thank you, and that brings me to the conclusion of my presentation. So thank you for your attention, and thank you for coming along to the webinar today. And before you go, I want to tell you about some other activities which are happening this week. We'll be holding an Ask an Architect session this Friday. So if you'd like to have a one-on-one session with an AWS architect, please register at the URL at the bottom of the page. And we'll also be holding a Question of the Week session this Friday, which will be fun end to the APAC webinar week. We'll take the 5 most commonly asked questions from all the webinar sessions this week and spend some time answering each one in detail. So we'll look forward to you joining us at the Questions of the Week session at the end of the week. And if you're interested in learning more about AWS, we offer a number of training courses, including online courses and instructor-led classes. We also offer a number of AWS certifications where you can validate your expertise with AWS and obtain industry-recognized certifications. And with that, thanks again for joining today's webinar. Don't forget to complete the survey, and the AWS team will stick around to the top of the hour to continue to answer your questions. So please keep posting your questions in the question window. And thank you very much, and have a really great day.